Hello and thanks for joining this talk. My name is Dana and I'm a software developer. I'm working at AppsFlyer and I started using Clojure 2 years ago when I joined AppsFlyer, and I'm lucky to be using it now as my day-to-day programming language. I will talk today about REPL-based debugging in Clojure, so I hope you will enjoy it. Let's start with a little bit about AppsFlyer and how we use Clojure in AppsFlyer. So AppsFlyer is the leading mobile attribution and marketing analytics platform. We basically help app marketeers around the world to get better decisions and get better insights on how their campaigns perform. We're a large Clojure workshop. Our main programming language is Clojure, and we have more than 200 developers using it in their day-to-day, and we have more than 200 microservices written in Clojure and running in production. Those microservices are running on more than 10,000 of servers, and by that we are processing the amazing amount of more than 90 billion events per day. So all new developers in AppsFlyer start their journey with Clojure with a training where they learn the basics of the language and they write some Clojure project. And then they have to set up their environment and understand how to use the REPL and how to use everything together. When I started this training, I learned Clojure and I did this project, and Clojure was my first taste and my first functional language. So I had to set up my environment, which includes the REPL and an editor, and I played with some editors. And then I had to figure out what is the right workflow for me and how should I use those tools. I learned all about REPL-driven development and about LangChain and how should I use those tools, and I started to get pretty comfortable and to feel pretty comfortable. But then I wasn't sure about how should I approach debugging my code. I mean, debugging is really basic, right? But something with the REPL and an editor and Clojure didn't feel the right thing for me, and I felt like I'm missing something, like I don't know how to do it in the right way. How should I work with those namespaces and the REPL, and how should I make my workflow fast and efficient? So this talk is totally back to fundamentals. I will cover some basic stuff, but basic stuff is our everyday stuff. And I hope you will enjoy it no matter if you're totally new to Clojure and asking yourself the same questions as I did, or even if you're an experienced Clojure developer. I will share with you some of the tools I learned to use, some of the basic tools like the stack trace and print, and how I can use them in order to make my workflow better. Then I will share with you the results of this exploration phase I went through and I'm still going through that made me write a library, a Clojure library called mate-clj, which aimed to help us Clojure developers to debug and understand our code better. And in general, is the right approach when talking about debugging with the REPL. So to start, let's talk about the REPL a little bit. The REPL stands for Read Eval Print Loop. And a small disclaimer, I will be talking and focusing today about the nREPL, which is the most common REPL used in Clojure, but the ideas are the same for all the REPLs. And the REPL is a great tool because it enables us, the Clojure developers, to interact with a running Clojure program. It gives us a fast feedback loop, which is great for a faster workflow. And in general, it has some utilities and some tools we can use in order to make our workflow faster. So let's start with the worst thing that can happen to a Clojure developer, especially a Clojure developer, and in general, every developer, the stack trace. So this is me every time I see a stack trace, and probably all of you. It's true that the stack trace can be threatening, especially Clojure stack trace. It's known as a pain point for Clojure developers. But we all know that when we are in development phase, when we have a stack trace printed, we know that we have an unhandled flow, an unexpected issue, and now we have the chance to deal with it and handle it before it goes to production. So you can learn a lot from the stack trace, but what happens if you get just an exception message and not the whole stack trace? So this was one thing that was surprising me when I started using Clojure. I saw that I get only the exception message printed to the REPL and not the whole stack trace. So the exception message was good, but not good enough. It provides some information, but not the whole information I need, because I can understand the exception and I can understand where it comes from, but I cannot understand from the exception message what was the flow that led to this exception. So I need to start debugging my flows and understand which is the problematic flow. So let's see an example. We have here a code which contains a config state. It's a mount dev state. Just has some data, a map for this example. Then we have my divide function, which gets two arguments, prints something to the REPL, and then tries to divide A by B. Then we have my calc function that takes two arguments as well, and then does some mathematical operations and calling my divide function in the end. Let's see what will happen if I will try to run my calc function with the data I have in my config state. So in this case, I will call my calc with the value of A and the value of B. So I'm getting here the print to the REPL from line number 13, and then I see I have an exception message. So from this exception message, I can understand that I got an arithmetic exception. I see that it comes from my divide function, and it happens on line number 14. So I can clearly understand that the issue is that I'm trying to divide something by 0 in line number 14, but I don't have the information to understand how I got to this my divide function, what was the flow that led to my divide function. I mean, this is a really simple example, but imagine yourself you have a function that is called by a lot of functions and the flow is getting complicated. It's really hard to understand. So actually the REPL stores the whole stack trace in a variable, the variable called star e. And knowing that, we can use the Clojure stack trace namespace using the print stack trace function, and we will pass this value of the variable star e. This will print the whole stack trace, and now we can clearly see that the exception not only came from line number 14, but the flow that led to calling this my divide function is from line number 19 and from my calc function. So this is great. Now I know the problematic flow and I can solve the issue and I can continue on developing my code. And when I change something in my code, I need to reload everything again and keep my data and my code synchronized. So this is the next topic, and to keep everything synchronized, we can stop the REPL and start it all over again, but stopping it every time and starting it every single time again will definitely interrupt our workflow and make it much more slower. So we need something else that will provide us the fast reloading we need, and we can use some tools we have without adding new dependencies in order to make it work. So the REPL starts with a default namespace called user namespace. You probably saw it in some of your coding. And there's no actual file called user CLJ in our source code, but if we will add a file called user.clj, we can use it as a utility namespace without pushing it to our jar and without having it in our production environment. So let's say I change the value of A in my map, my config map, to be 10 instead of 0. Now I need to reload everything again and run my function again to see if I get a different result. So using this user namespace, I wrote some functions that will just clear the plate and start all over again. So I will call my main function, the same semantic we have and we know from the core of the program. This main function will call reset function. The reset function what the reset function basically do is just stopping the states, so it's clearing the plate. Then it's refreshing the updated or the edited namespaces to the REPL and load them again, so we get the updated code. And then we will call the go function. And what go function will do is that after we have the updated code in our REPL, we can load the states and get the updated data. So we will get synchronized data and code together. So back to the example, we will run now the main function, and we can see that it's stopping all the states, then refreshing the code and reloading the updated namespaces to the REPL. After it's finished, we will start all the states again and get our updated data. When it's ready, we can use the REPL, and it takes really small amount of time. So now let's try to call my calc function with the updated data, and we can see that we don't have any exception because now it's a valid division and we can divide 11 by 10. So state reloading is a very cool method that provides us the ability to use the default user namespace without adding any new dependency or external dependency to our code. It provides us the ability to sync between our data and code without stopping the REPL. And the most important thing, fast reloading and fast workflow. I recommend you reading this reloaded pattern that was introduced by Stuart Sierra. It's a really interesting read, and I think all of us should read it. So now we're all good. We know how to use the stack trace, and we know how to synchronize our data and code together after we make some changes without stopping the REPL and keep our workflow fast. But still, we will have some cases, or we have some cases during our development where we run something and get an unexpected result. It's not an exception, it's not an issue, but it's not the result that we expected to get. And we need to try to understand how we got this result and how we can fix our code to get the expected result. So let's talk about code flow debugging. Let's go to an example, and let's say we have a map. This map contains a vector, a list of languages, and let's say we want to just call a function that will return the first argument of this vector, which is Clojure, and will print Clojure is awesome. So for this example, I will use a threading macro. I personally love threading macros. It makes the code much more clean and clear, but sometimes threading macros can get complicated and it's really easy to get lost by the flow. So for this example, I will keep it simple, and let's see what we're trying to do. So I have the map. I will try to get language key and then get the first element and add it to the is awesome string and return it to the REPL. So let's see the result, and I'm getting here just is awesome without Clojure. So something is wrong here. I'm not able to get the first element of the vector, and I'm getting just the is awesome result. It's weird, I'm not sure why it happens. Probably something is wrong, but I need something that will help me understand what is wrong. So let's use prints for this example, and in general it's a very great tool. It's simple, it doesn't require any new dependency, it's provide fast feedback loop because it's just a single function, and the most interesting part is it can be combined in threading, in macros and in functions, in macros like the threading macros we saw, and it's really easy to use them. So back to the example, let's add some prints to this threading macro. And now we will use the do-to function that basically takes an argument, execute the function inside with the argument, and return the same argument as a result. So it's good to use it here because it won't affect the threading macro flow and the data that each step is getting. So let's see. The first do-to will print the map. The second do-to will print nil, which is weird because I expect to get the whole vector of the languages. But then when I look at it, I see that I have a stupid typo. And it's a stupid error and a stupid example, but those kinds of error happens all the time. And it's really important to find them quickly and solve them quickly. And of course I get the final results. So now, with just adding 3 lines of code, or simple code, just prints to the code I wrote, in less than, I don't know, a few seconds, I've got my answer, and now I can fix my code and get the expected result. So that's great, right? We can easily solve everything we have on most of the issues we have with debugging our code, but you're not going to really go over line by line and add those prints and then remove them, or go all over your projects and add it. It's really exhausting, and I found myself trying to understand how can I understand my code flow when I need it without adding those prints manually. So I'm happy to introduce mate-clj. I use this method again and again, and then it made me write this library, which just combined those prints in the core functions and core macros of the language. Mate-clj is a Clojure library that gives better visibility on your code flow. And the important thing is that the functionality of the macros and functions remains the same, but you get the steps of the execution printed to the REPL, and it's really easy to understand by that the flow. So let's see a demo. We have the same example, but just adding the require namespace of mate-clj. And instead of using the regular threading macro, I will use now the D threading macro of mate-clj. D stands for debug, so it's really easy to remember it. And now I'm not getting just the result of each step like we got with the prints. I also get to see what is happening in every step and the result of the execution of this step. It's really clear to understand how we're getting the final result by using this macro. Another nice example is using the cond with the threading macro. If I would tell you that the result of this execution is 918, you will have to go over line by line, understand if it's true or false, then calculate what you have to calculate in order to get the result for the next step, and get to the final result. It will take some time and it's exhausting. Using mate-clj, it's really easy to see what is happening in every step and what is the result, and by that it's really easy to understand the final result. Another example is using the reduce function, and again we can see the result of each execution step and the final result, and it's really easy to understand how we got to this final result. There are much more functions, macros covered by this library. You're welcome to use it, and of course pull requests are always welcome, so you're welcome to contribute to this library and learn from it. And the last topic I want to cover today is using logging libraries. So we talked about prints and how they can help us understand the code flow, but sometimes we will need an advanced print capabilities. So advanced print capabilities gives us things like level tagging, which can filter some of the prints we have by level, like info, warning, and etc. We can get information of the line number, where it was printed, and the namespace, the source namespace, and of course all of these features with a low overhead on our code and our running program, which is really important. So this example, small example from Timber, which is a recommended logging library and which we really like in AppsFlyer. So for this example, we have an error log that gets a random message. And printing this log, we will see that the date and time that this log was printed. It's really helpful. The log level. Then we have the namespace and of course the line number. We will also get the message itself, and we can pass arguments, data structures, everything we want to print to the REPL. So those are some logging libraries you can use and try, and it's really nice method to get some advanced print capabilities and more information that we need during our development or even when we run the code. So to recap what we talked about, we started with the stack trace and how we can use it and where it's stored. And how we can understand the problematic flows and solve them fast. We talked about synchronization and how we can keep our data and code synchronized without stopping the REPL and starting it again and keep our workflow fast and productive. We talked about code flow debugging and how we can use such a simple tool like prints in order to get better insights on how this code flow is going. And of course I introduced you mate-clj, which is the library I wrote and helped me understand a lot of flows and a lot of flows of macros from the function, and it gives those prints capabilities out of the box without the need to add a print line by line. And finally we talked about logging libraries and how those advanced print capabilities can help us and can improve our experience. So to summarize everything, I think that the REPL is a powerful tool and we all should use it, and it should be native to our development flow as Clojure developers. I highly recommend you to know it and to use it regularly. And remember that every line of code we write, we will have to debug someday. If not now, then in a week, if not in a week, in a month, and it's important to do it efficiently. And as this quote say, every new line of code we willingly bring into the world is code that has to be debugged, code that has to be read and understood, code that has to be supported. So this quote is by Jeff Atwood, which is Stack Overflow co-founder, and I found that learning a new language is always exciting and fun. And from personal experience, I can say that learning Clojure has proven as a fun ride. I found that a good way to be really able to get a good grasp on a new programming language, and especially for me, in Clojure, is by understanding how to debug it properly. So thank you for listening and safe debugging.